Welcome to Smiles Laboratory. In this laboratory, we specialize on mechanics of impact and leakage through the tools of experimentation and simulation. When we say impact, we are talking of impact of elastic bodies as well as impact of fluids on elastic bodies. Elastic impact is encountered in motor car crashes, in bullet impact, sports impact, and so on. When we talk of impact of fluids on solids, we see them in blasts as well as the impact of medicinal oil on foreheads of human beings in treatments like Shirodhara in Ayurveda. When we say leakage, we are talking of failure of interfaces, where we try to investigate the conditions under which two interfaces separate from each other, and also examine how a fluid will flow through the weak interfaces. In leakage, we are investigating separation of interfaces, the conditions under which the separation takes place, as well as the movement of fluids through these weak interfaces. These are important in the design of seals in high pressure applications as well as in many nuclear type of industries. Our interest in this lab is also to look at failure of solids and structures through the processes like fracture and damage that invariably are there in all solids.
Shirodhara is an Ayurvedic brain relaxation therapy. It is useful for treating various neurological disorders like mental stress, anxiety, depression. The mechanism involved is the impact of medicinal fluid on human forehead at controlled temperature for particular time duration. The experiment was conducted in our lab with the help of professional Ayurvedic therapists. 17 healthy volunteers were recruited. The medicinal fluid used was Shirabala oil. Each volunteer has undergone 7 days of treatment. The work plan for single day is as follows, where before treatment EEG data was collected. Then the subject undergoes treatment for 30 to 60 minutes for day 1 to day 7. Post treatment again EEG data was collected. Here in this video we can see a subject undergoing a Shirodhara treatment with the help of therapist. 14-channel EEG headset was used for data collection. The data was in raw form. Various filtering methods were applied to get in pure form. The feature extracted was a spectral power. Apart from that one, various psychological as well as questionnaires data were collected from the volunteers. Some of the results are as follows. The alpha by beta ratio post-treatment has increased from day 1 to day 7 except in day 4, and the alpha by theta ratio post-treatment has increased from day 1 to day 7, which indicates the subject feels very relaxed and calm post-treatment.
We have gone through the effectiveness of Shirodhara and found out that it is indeed a very good method to treat ailments related to mental state. But this raises one more question. How does it actually work? Being dependent upon various unexplained empirical rules, it is important to study the mechanics behind it as well. The whole arrangement from mechanics point of view mimics the classical fluid-solid interaction problem as shown in the general setup. The first step to study the mechanics of Shirodhara is to characterize the flow and the parameters associated with it. Here at Smiles Lab, we ran a simple experiment in which the oils were allowed to fall under the influence of gravity. The dimensions associated with the experiment were analogous to the ones which are there in the ancient text. One flow example has been shown here. The recorded flow was then processed to get the boundary of the developing flow and to capture the dimensions associated with it. This information about the boundary then helps us in calculating the parameters associated with the flow. After calculating the velocity and area of the tip of the developing flow, it was found that the velocity was increasing linearly, which is to be expected since the major driving force in this experiment was gravitation, and the area was decreasing hyperbolically, which satisfies the continuity equation. After the calculating the Reynolds number, it was found out the unexplained empirical rules which are there are to ensure that the flow stays continuous and laminar. This study opens up the avenues to study the impact process of this treatment method.
A number of games like cricket, tennis, baseball, and golf, etc., involve impact events which are very critical to the gameplay. For designing better sports equipment and for preventing impact injuries, study of impact is very necessary. In our lab, we are studying the mechanics of various impact scenarios occurring in the game of cricket. One of the most important factors in the game of cricket is how the ball interacts with the pitch and the bat after being bowled, causing it to deviate, turn, or bounce unexpectedly. We are currently using finite element approach to understand the behavior of common impact scenarios like bat and ball impact and ball and pitch impact. Collision and impact mechanics associated with the cricket governs the engineering mechanics which has to be studied for proper understanding of the game and to augment the sport performance in terms of reliability, safety, and entertainment.
High strain rate behavior of ceramic materials. Ceramic materials have superior properties like high hardness, high specific strength, shock resistance, etc. So, ceramic materials can be used in impact-related applications such as bullet armor, vehicle, and building protection. In body armor systems, ceramic materials such as alumina, silicon carbide, and boron carbide are used as strike-face material. The main failure mechanism of this material is the crack generation, propagation, and finally the coalescence of cracks. In such applications, the material undergoes deformation at a high strain rate under high pressure. To analyze such events, experimentation and development of the material model are required. Split Hopkinson pressure bar or SHPB test is used for high strain rate experiments. SHPB works based on one-dimensional wave propagation theory. Strain gauges were pasted on the incident bar and transmitted bar to capture incident, reflected, and transmitted pulses generated due to the wave propagation through the bar and specimen. These pulses are post-processed to get the stress strain curve at a different strain rate. Specifications of SHPB in the high rate impact measurements laboratory are given here. In this study, alumina ceramic is tested using SHPB. These are some images of the test setup in Green Lab. For the high strain rate testing of brittle material like alumina, pulse shaping technique is required to achieve constant strain rate and dynamic equilibrium conditions. We used a thin copper plate as the pulse shaper, which is placed at the end of the incident bar. Copper pulse shaper converts the trapezoidal waveform into ramp-shaped signal. The effectiveness of the pulse shaper is also studied by considering the ability to achieve constant strain rate and dynamic equilibrium. For this, peak strain rate to average strain rate ratio was used, and this value improved from 5.1 to 1.7 when we used pulse shaper. Input-output forces on the specimen and face also matched well with the use of pulse shaper. Noise in the stress strain curve is also reduced in the experiments with pulse shaper.
Studying energy absorbing structures which actually provides maximum occupant safety in a crash event. So there are a few components like crash box, B-pillar, which actually protects the occupant in an event of crash. But the current crash CA doesn't account for rate effects such as dynamic fracture, effect of forming or strain part during part manufacture. As we all know, 90% of plastic work is changed to heat, and there could be temperature increase due to strain rate, and there could be local softening due to which the failure behavior of the part itself could be changed. So in order to study this, we need to investigate the effect of stress state on high strain rate behavior and fracture of the sheet which is used on automotive. So even before crash, there could be forming of the component as well, and there could be part dependence which could actually influence the crash. The current fracture modeling actually takes quasi-static loading into account. There could be different stress states at which experiments could be done. But in reality, we should be having dynamic loading, the equivalent strain to fracture. It should be mapped based on high strain rate loading with changing stress trajectory. So there is a scope to study the effect of strain path as well as dynamic loading on failure strain at different tracks. In order to complete the investigation, there will be utilization of experimental resources like high strain rate machine. There could be basic mechanical or forming experiments which could be done for this project, and there will be also constitutive modeling and simulation using workers, and at the last there could be prototyping and stress testing of actual component which could be done either at Tata Steel or at ARA.
Creep fatigue interaction problem commonly seen in the critical components of aero engine and nuclear reactor. For proper designing of these components, understanding of the material behavior under complex creep fatigue interaction is important. Fatigue refers to the failure of material due to repeated cyclic loading. Creep is a tendency of a solid material to deform permanently under the influence of persistent mechanical stress. This is a time-dependent failure which is more severe when the material is subjected to high temperature. The figure shows the interaction in which a material is subjected to a few fatigue cycles following the hold time. The creep fatigue group at the SMILES lab are investigating aero engine specific nickel-based superalloy. The load cycle, which is a strain time variation in the middle figure, indicates first hysteresis loop and second the hold time results in the stress relaxation in which material relaxes. In the metallurgical aspects of the creep fatigue interaction, a few voids can be observed which are formed due to the mechanism of grain boundary sliding, and these voids become initiation sites of the fatigue cracks. The interaction of both of them may be a culprit for their failure. In the bottom figure, you can see a turbine blade and the morphology of the fractured part in the creep fatigue test. There are plenty of models available which can predict the life of an aero engine alloy under the creep fatigue interaction, but most of them are phenomenological and empirical in nature. In 1998, Professor Bassaran and Ian developed a theory which caters for the thermodynamic state of the body subjected to loading. The unified mechanics theory uses a entropy based apart from the XYG axis and the time axis present in the Newtonian mechanics. Unified mechanics theory considers a entropy axis, that is entropy based TSI axis, which takes care of the internal degradation of the material. To predict the interaction, we are using in-house developed creep fatigue model based on UMT. So we have already predicted the stress relaxation part and calculated the degradation during first cycle, and we are moving ahead with the prediction of the number of cycles for the failure.
An electric battery is a source of electric power consisting of one or more electrochemical cells. Batteries have their application in various sectors, for instance, grid energy and industry, consumer electronics and devices, and transportation. The consumer electronics and industry is well developed as far as the application of battery is concerned. However, the utility of batteries in vehicles is not as per the requirement due to various challenges like input cost and safety. An electrochemical cell consists of a pair of porous electrodes, negative and positive, with a porous separator in between. This setup is sandwiched between metallic current collectors. During the charging cycle, the electrons from positive electrode moves toward the negative electrode through the external circuit, whereas in lithium-ion batteries, the lithium ions move from positive electrode to negative electrode through the anically conducting electrolyte until the battery is fully charged. During the discharge cycle, when the load is connected to the external circuit, the electrons and lithium ions move back to the positive electrode via the external circuit and electrolyte respectively, thus producing electric current. Some SEM images of electrodes and separator are depicted in this slide. The pores present in these materials aid in transportation of lithium ion from one electrode to another. Quantum battery models generally fall into two categories: empirical and physics-based. Empirical models focus on incrementally adjusting equations and their parameters to find the best fit for the experimental data and are thus used in battery management system. In contrast, physics-based models represent the physical phenomena underpinning the battery behavior and are used to produce highly accurate simulations of battery performance and interrogate its internal behavior. Different types of physics-based models are microscale model, homogenized model, DFN model, and single particle model. A degradation model takes into account all the degradation mechanisms at the positive and negative electrodes like formation of solid electrolyte interface, phase change, oxygen evolution, particle fracture, and lithium plating. We at the SMILES lab are attempting to model the degradation of batteries used in electric vehicles using unified mechanics theory.
Development of ratcheting design rules for the modified G91 steel is the international effort of designers and code developers for the Generation 4 and fusion reactors. Because the ratcheting design rules are originally developed focusing on austenitic stainless steel, which harden under both monotonic and cyclic loadings, which is quite different from G91 steel. In the case of G91 steel, the number of load cycles to attain a saturation condition is very high, while the ASME based ratcheting design rules were established basically from the analytical roots, while the RCCMR, which is French based approach, adopts experimental roots. Code conceived robust benchmark like ASME conceives pressurized elastoplastic thin shell subjected to cyclic through the wall temperature gradient, but the RCCMR, which is French based, adopts tension torsion bars. The numerical simulation of ratcheting has been reported on these two benchmarks, but employing a new 20-parameter Chebosh model for G91 steel. The predictionability of the model on uniaxial material properties that govern the ratcheting phenomena are demonstrated. Based on several data derived from the numerical simulation at various temperatures, a typical diagram is plotted in figure number 1. As you can see here, the stress fringes in the different colors. The bottom line simply shows the uniaxial loading, but the top line shows the biaxial loading. Besides the numerically simulated points, along with a few more data generated from the tension torsion test, are depicted in a new efficiency diagram that is proposed by France in figure number 2. It is concluded that Brie diagram can be applied for the base metal portions of components to protect against ratcheting.
Monitoring and improving health of rural SC communities and surrounding hamlet villages by using IT tools. Addressing health status survey by using IT tools. India was prosperous and healthy before advent of the British. Every mother and grandmother knew some Vaidyam at domestic level. There were expert Vaidyas in every village. That's why we have chosen to do a nice pilot project in Palagottapalli, 4 hours from our IIT campus and 2 hours from Tirupati. Implementation in rural areas. Once in a month, we take online session to villagers by using doctors. Once in 2 months, we conduct medical camps and we monitor by using a software. How to integrate technology to traditional health system by providing a good solution. Ayurvedic doctor with minimum data. Lot of health application softwares are there, but it is designed for a health campus in a simple way. Basic Idea is to understand patient details in each camp so the doctor will be in a position to diagnose and quality the health prescription can be given. Health camp management software we are going to provide. And importance of using health software: easy to handle and use, data is easily accessible, recovery rate will be known easily, chronic diseases are identified and send them for better treatment. Final goal of the project: small Ayush center with the help of Government India, local health partner at the already village level already initiated.
Research is an enriching and an enlightening experience. It involves several factors. It involves, number one, identifying gaps of knowledge that exist within your chosen field of investigation. Number two, it involves focused attention and focused thinking for a period of times in order to develop a hypothesis that may solve a post problem. Number three, it involves a testing of this hypothesis using tools of experimentation and logical thinking, which some people call as mathematics. Finally, it involves precise articulation of one's results. An articulation that is sharpened by tools of debate with other peers in your own field. Research is not merely an ego-boosting trip where one tries to prove that one is second to none at a particular time in a particular field. It is an enlightening experience where we discover ourselves and the wonderful laws of nature and a relationship between ourselves and this beautiful universe which some people call as God. Research experience will help us to keep smiling and carry these smiles all through our life.